Good morning, everyone. As promised from yesterday, today we're going to start talking about lines of best fit. Okay, so in this lesson, we're going to review how to set one up, the equation. Okay, but we're also kind of going to talk about how quote unquote good a line of best fit can be. Okay, so there's a little bit of definition work up front to set this up. Okay, so again, please go to your notes here. We have seen / created scatter plots and lines of best fit using technology. Okay, so again, yesterday we were drawing some graphs on the computer there, and in the past you've probably done it as well, and we will get into Desmos in a little bit. Okay, tomorrow. You may have noticed that some lines seem to fit the data better than others do. That is, sometimes the data points are more tightly packed to the line than other times. Okay? In statistics, we call this idea correlation. So, for example, while you're taking this part down here, okay, I'm just going to do the two little sketches. Okay, we'll put some points on there. Okay, so we're trying something like this, maybe as opposed to this. Okay, right? Both graphs, okay, show some bit of an upward trend. Okay, right? The points are moving upwards to the right. Okay, but if I were to sketch a line of best fit, okay, I might say for that first group of points, the points fit much, much better than the second group, okay, because they're much closer to the line of best fit. Okay, that's the idea we're trying to getting at here or trying to describe. Okay, correlation is a description that tells you, how good or how close are your points or how close is your data to your line of best fit that's approximating this relationship. Okay, so that's what correlation is. In statistics, if you're looking for a connection between something, okay, then you would hope, right, you would want the graph on the left, right? The closer it is, the more likely that the relationship actually exists because they are all following a very clear pattern there. Or in the second graph, because they're more spread out, right, there's much more space around this one. Okay, there might be a connection, but it doesn't seem to be as strong. Okay, that's the idea here. Okay, so as I mentioned there, this is an important definition. Okay, come around test time. Correlation is a measure of the strength of the relationship between two variables. Okay. The correlation coefficient, okay, and we're going to use an R for that, is an indication of both strength and direction of a linear relationship. The value of R ranges between -1, which is what's called perfect negative, and +1, which is perfect positive. The value of 0 indicates no correlation. Okay. So underneath here, I'm going to sketch what those would look like. Okay, going to start with R equals 1. Okay, perfect positive correlation. Okay, perfect positive means, okay, 1, because it's perfect, that every single point is on the line of best fit. So if I drew this out, okay, even there I've gone off a little bit. Okay, but if I connect the line of best fit through those points, okay, and set it up properly, it's going to hit every single point. Okay, right? They're all in the line. Okay, that's what perfect positive correlation is. Okay, so not only do they like appear, they are a line of best fit. It makes a line, and it's positive because it's going up. I can see the points now. Okay. Perfect negative correlation is the same idea. So we have R equals -1. Okay, that just means that again, it makes a line of best fit, but it's going down. Okay, so something like that would have perfect negative correlation. R would be -1. Okay, as the dots start to get more spread out, so for example, building off that -1, the -1, okay, let's say I have a downward trend, but they're a little less like a line. So there's a little bit of movement back and forth. Okay. So again, if I add a line of best fit, there's a little bit of space around them. Okay, so we might say that that has a correlation coefficient of R equals, it's negative because it's down, maybe 0.9. Okay. The more spread out they get, so let's say if I add a few more dots here, okay, so it's still going down, but it's starting to spread out more, right? Maybe that would be negative 0.5. Okay, so the more spread out it gets, the smaller the value gets. Okay, so your worst possible case is if you have a value of 0. Okay, if your correlation coefficient is 0, then you basically have no trend that you can identify. Okay, and there's a couple ways that can happen. So I'm going to draw those out here. Okay, the first option for R equals 0 okay, is what we were just talking about there. If they were so incredibly spread out, okay, that there's nowhere to draw a line of best fit. Like, who knows where you're going to put that, okay? So that is R equals 0, okay? The other option for R equals 0 okay, is if it's a perfectly flat, pretty much a flat line. Okay, if it goes straight across, then R equals 0. Okay, because it's not positive or negative, right? It doesn't trend up or doesn't trend down, it stays flat. Okay. Okay, so that's what R is. Okay, a related number is R squared, okay, which is the coefficient of determination. Okay, which again, like it says, it's R squared. So to find it, you just have to square your value. Okay, so what that is, it's a measure of the degree of confidence in predictions that you make from line of best fit. Okay, for example, if R squared is 0.81, you can be 81, say that 81% of your predictions would be accurate. Okay. Again, we'll talk more about that one later. We're going to focus on correlation now. But yeah, basically it's saying, if I take my line of best fit, so for example, the first one would be R equals 1. Okay, if I make a prediction point at the end of it there, well, 1 squared is 1, so I can be 100% confident that's right on. Okay, it's definitely in the right spot. Okay, which would make sense, right? If it's a perfect trend, I know exactly where it's going. If we're using one of the other ones, say the 0.5, okay, if I add a prediction point on there, now that's more of a little blob, but if I do a prediction point there, well, it's on the trend line, but there's a lot more uncertainty as I have this extra space. Like maybe the point should really be up there, or maybe it should be over here. Okay, we don't know for sure. So my degree of confidence, okay, in this prediction would be a lot less because there's more variability in the data. Okay. Okay, so for our first example, okay, again, don't feel like to perfectly copy these down, these pictures. Just take a minute, maybe just a good place to pause, okay, and just chat with your neighbor for a minute, if you were going to give an estimate of what the value of R was for these graphs, what would you say that it is? Okay, so now if you're back, let's talk about them quickly here. Okay, for the first one, okay, we have an upward trend, right? And if I was to draw a line of best fit there, it'd be pretty close. Okay, they're very close. So maybe we'd give this a value of R equals 0.9. Okay. Okay, 0.95, like something a very like close to 1, but it's not perfect. Okay. For the second graph, okay, again, if we add a line of best fit, okay, there's a definite downward trend, but it's much more spread out. Okay, so that one might be, let's say, negative 0.6. Okay, so moves pretty solidly, but it is more spread out. Again, as long as you're in the neighborhood, okay, it's okay. Like if you said this was negative 0.1, I'd say no, it's not that spread out. But if you said 0.5 or 0.7, okay, somewhere in there, you'd be okay. Okay, and for C, hopefully you agree that R is equal to 0. Okay, I can't really add a line of best fit there and have it make any sense. Okay, like it's all over the place. There are other patterns you could do. Like for example, if I connect the dots a bit here, I almost have a bit of a bunny rabbit in the middle. Okay, but right, there's no obvious way to draw a line of best fit. So its correlation is 0. Okay. So for our second example, now we're going to review how to kind of graph these out and do a line of best fit by hand. Okay, so if the correlation is strong, right, it's a good trend, then we can do a line of best fit by hand, okay, and we can determine its equation algebraically, right? So the way that you did in kind of grade 9, grade 10, finding the equation of a line. So here's the example we're going to use. Okay, so a cyclist is training for a touring race. Okay, he keeps a record of how many hours it takes to complete a set course each day. So, right, practicing cycling over the same distance over and over, and here are the times for that. Okay. So what we're going to do is we're going to create a scatter plot. Okay, and then we're going to draw the line of best fit and try to figure out its equation. Okay, so at this point, okay, you might want to grab some graph paper. Okay, if you don't have any of your own, there's a very big stack on the shelf on the right side of the classroom if you're facing the board. Okay, so make sure if you want some that you get it. Okay, and we'll try to make a nice graph here. So just following our columns, right, we would have day would be on the bottom. Okay, and the time is going to be up the side. Okay, and I'm just going to move my table here. Okay, so let's plot the points. Now, again, because they're all in a pretty tight range, okay, I set up my scale to reflect that, right? I have a jump at the bottom. Right, so this being right here, the little zigzag means I'm jumping, and you can see we're starting at 2.5 and then just going up to 3.5. Okay, so we'll add our points to the graph. So there's our points. Okay, magic of technology, they're just there. Okay, so again, this would be a good place to pause, make sure everyone gets their points in the right spot on their graph. Okay. Okay, so from here, we're going to add a line of best fit. Okay, again, these points are really close together. So it's not too difficult to draw a line of best fit. Looks like it starts maybe just under that point. Something like this looks reasonable. Okay, we can can tweak that a bit. Okay, it's probably easier for you with a ruler than it is for me with the technology. Okay, let's say that. Looks pretty good. Okay, so we have our line of best fit. Great. Okay, now we want to create the equation of the line of best fit. Okay, so let's just quickly review here what we're going to need. Okay, so equation of the line, the one you've learned over and over again, right, is y equals mx plus b. Okay, and so the two key things we need here are the slope and the y-intercept. Okay, so going back to our graph, okay, ideally, if we have a couple of points that are pretty much on the line, those are probably the best ones to use. Okay, so for example, this one here, right, that's bullseye, that's right on our line of best fit. Okay, and a couple of ones nearby, like this one at 9 is not bad. Okay, and the one over here at 3 is not bad either. Okay, I'll take the one at 3. So those can be the 2 points we use. Okay, so 3 and 3.15, 7 and 3.08. Okay. So we'll start by finding our slope. Okay, so on the side here, okay, our formula for slope. And again, this will go back to grade 9 or 10. Right, slope is equal to y2 minus y1 over x2 minus x1. Okay, and I'm just going to copy over our points. We had 3 and 3.15, I think. And 7 and 3.08. Right, so those are our x and y coordinates, right? It's always x and then y. Okay, this is my second point, this is my first point. So now we just fill in the formula. Okay, so y2 is 3.08, y1 is 3.15 over 7, take away 3. Okay, so let's see here. We get it's over 4. Okay, so we take that and divide by 4. Negative 0.0175. Okay, so very gradual improvement here. Okay, we've got a slope. Okay, so we can put that into the equation. Negative 0.0175. Okay, so as for the y-intercept, okay, we have a couple of options here. One, if we go back to our graph, okay, we could try to just eyeball it from the graph. Okay, so from the way I've done the line of best fit, okay, it looks like it's hitting pretty much right at 3.2. Okay, so I could just say my y-intercept is 3.2 and be done with it. Okay. Okay. I'm going to review how to do it the other way, okay, in case it's not quite as obvious. So the other way you can do this, to get my y-intercept, okay, now that I know my slope, I can plug in one of my points, right? So let's say I'll use the one that was right on the line, okay, this one. Okay, and I can put that in for y and x and use it to solve for c. Okay, Yeah, sure, we'll go green. So my y here was 3.08 equals negative 0.0175 times 7 plus b. 3.08 equals negative 0.1225 plus b. Okay, and last to solve for b, we'll bring that negative 0.1225 to the side, which makes it positive. So that's equal to b. Okay, and when I add those together, 3.2025 is b. Okay. So yeah, just like we saw on the graph, it is really right about 3.2. Okay, so finally, therefore, the equation is y equals negative 0.0175 x plus 3.2025. Okay. Okay. Again, what would be the point, right, of doing this, or what's potential use here? The potential use would be, if I go back here for a second. Okay, let's say this guy who is training for the bike race is racing a total of 30 days after he started. Okay. So assuming that the trend will continue like this, right, I could make a prediction. Okay, what would happen on day 30? Okay. So again, the way we had this set up is that x would be our number of days. That was our x-axis. So now I could just plug it in. Y equals negative 0.0175 times 30 plus 3.2025. So the calculator work there. .6775. Okay, which is around 2 2/3. So basically, after 30 days, he'd be down to about 2 hours and 40 minutes, and he was right around 3 hours at the start. Okay, yeah, so that's what the process looks like. So thank you for taking this down. Okay, for practice, okay, there's some questions from the textbook. Okay, some of them just ask about correlation. Okay, and some of them would like you to make a graph and get a line of best fit. Okay, which would be excellent practice for what you need to do here. If you need some rulers and things on the back of the iPad cart, there should be a little box there that's got some rulers on it. Okay, so yeah, this is what I'd like you to work on. Okay, tomorrow we'll talk a little bit about how to do this with technology. That'll be part of tomorrow's lesson. Okay, so how to make the calculate correlation and make lines of best fit with tech. All right. Thank you for watching, and I will see you tomorrow.